Okay. I used to do this on my whiteboard, but I've already got the problems worked out on my iPad, so I'm just gonna run through basically where we're at for this. So this is the second question for the test. This is where we have a car that's on a banked curve and of 20 degrees, and it's a frictionless surface, and they want to know the radius of the circle. They give the mass, which is 1,200 kilograms. I've converted that here to, oh, sorry, no. The mass is 1,200 kilograms, and then the velocity is 45 kilometers an hour. And I've converted that here using the ratios to meters per second. So we'll use that in a little bit. But basically, centripetal acceleration is going to be velocity squared over r. We don't have any friction, and so the only force vector that we have in the x direction is going to be the x vector of the normal force. And so if we sum the vectors, we know that n sine of theta, which here would give us the opposite, which is the x value. So n sine of theta, which is the force in that x direction, is going to equal to our mass times velocity squared over r. In the y direction, we should have whatever n cosine, which would be this adjacent portion of theta, minus w should equal 0 because we have no acceleration in the y direction. So solving for n, just rearranging this to isolate n, we get n equals the weight over cosine of theta, which is the same as mass times gravity over cosine theta. So we take this, plug it back into our equation for n here to solve for our radius. So that math is done here. So the w over the cosine of theta times the sine of theta is equal to mv squared over r. These two create the tangent of theta. And so rearranging this, multiplying r by both sides, and then dividing it by the tangent, or the mass times gravity, which is the weight, times the tangent, we isolate r here. So now we just got to plug in the variables, and that's what we've done right here. So 1,200 kilograms times 12.5 meters per second squared over 1,200 kilograms times 9.8 meters per second squared, which is gravity, times the tangent of 20. Hold on one second, Mac. 1 second, buddy. So the radius is going to be equal to 48 or 43.8 meters for a car that's going around a turn at a 20-degree angle on a frictionless surface traveling 45 kilometers an hour.